Now, in the first wave of Azure services that we're going to use is our migration from MongoDB to an Azure Cosmos DB. So this section will cover Cosmos database, how to deploy it on Azure, and how you can integrate Cosmos DB with Azure monitoring. So starting with the Cosmos DB high-level overview. In short, Cosmos DB is a globally distributed, massively scalable, multi-model database service. So it supports different database models, a table API, Cassandra, SQL, and Gremlin for Graph. It's redundant by design, and it's built with performance at scale. The high-level architecture of a Cosmos database starts with an account, and mapping it with the Azure platform, it's the name of your database, .documents.azure.com. Inside your account, you create a database. Within the database, you create container called collections. And inside your collections, you're going to store your actual database items called documents. So the first step is deploying your Cosmos DB on Azure. Deploying an Azure resource, not really mattering what resource it is, it gives you an integration with Azure CLI, command line interface, Azure PowerShell, Azure Portal, or using an automated Azure Resource Manager template. What I'm going to do in this section and using some demos is using the cloud command line interface, Azure CLI. So just a couple of scenarios here using AZ Cosmos DB, where you point to the name of the Cosmos database and the resource group, and most important, defining the API you want to use, being MongoDB in our example. If you're more into PowerShell, know that you can manage Azure by using PowerShell, deploying new resources as well, using PowerShell new Azure RM resource, and defining the specific characteristics. Or if you want, using the portal, you start with creating a new resource, searching for the Azure Cosmos database, where you provide an account name, selecting the API, defining the location, being the Azure region where you run your database, defining if you want to use geo-redundancy, yes or no. And as you can see here, the default is geo-redundancy being enabled, and even allowing multiple region rights or not. I'm going to deploy an Azure Cosmos DB using the Azure portal. So what you can do from here is searching for a new Azure Cosmos DB. We need to provide some information like I walked you through in that slide deck, creating your subscription, the resource group. I already have one just from some previous testing, where we're going to create a packed Cosmos DB using MongoDB as the flavor and deploying it in, why not, Central US. I'm not going to use geo-redundancy for now, because I'm going to talk about that one in my high availability section, and it means I'm not allowing multi-one. I can also integrate with on-prem or Azure running virtual networks. I'm not really using those for now, and that's pretty much it takes to create my Mongo database. So I'll keep it running, takes a few minutes, and then I have my Cosmos DB active. I can actually walk you through the creation using the MongoDB Azure CLI. Azure CLI can start from my local machine, but I can also run it from within my browser. If it's the first time, then it's going to ask you what version you want to use, Bash or PowerShell. I don't really use PowerShell that much, so I'm going to use Bash in my environment. And it starts with creating a new resource group, for which I'm using AZ group create, and making it a little bit more specific to what I'm building here, avoiding any overlaps with previous testing to make sure that actually was running fine. So what I have now is a new resource group called packed Cosmos DB RG in a location Central US. So the next thing is creating my actual Cosmos DB database, and that's done by using AZ Cosmos DB create, and I'm just going to type it in to just emphasize how easy it is. Packed Cosmos DB, pointing to the resource group that we created before, packed Cosmos DBRG. And most important, the kind, like what is the API you want to use, or like the database flavor would be MongoDB. And that again takes a little bit of time. And in meantime, I'm not going to wait for it since I already have one deployed. So I'm going to minimize this and going back to all services, searching for Cosmos DB. There we go. And what I have here is my Cosmos DB environment. And most important is my connection string, for example, since that's what I'll be needing in my Node.js application. But besides that, I can browse to the data inside my database. So I don't need to go through this command line Mongo option anymore that I showed you in my on-prem environment. And from here, I can browse my documents, where again, a document is just an item inside my environment. So one of my tasks was running an Azure Cosmos DB, testing App Insights, and adding something else. Cool. So the next thing I'm going to do besides creating my database is really connecting. So what you need is changing my local application database pointer inside my Node.js application and using the connection string that's been offered out of Azure. So what I'm going to do right now is flipping back to my Node.js application, and this time updating my database JSON file, where I'm going to update my remote URL where it says paste your Azure Cosmos DB. That's pretty easy. That's where I'm already am in the portal, and I'm going to copy this primary connection string. As you can see, there's a primary and a secondary one to just make sure that every now and then I can just change it. And if there would be only a single one, then it would break my application whenever I would make those changes. So in the meantime, my connection settings have been updated. And next to that, inside my server.js, this time I'm going to document or comment out my local, and I'm going to activate my remote URL. Saving, I don't need a breakpoint here. Saving the changes, and let's see if we have our application. There we go, npm start. And this time it should point to my Cosmos DB database. Something got wrong here. Let's see. Did I forget to save my information? Remote URL is fine. My connection string is fine. Let's try that again. Let's see if I have any other. My app was still running. That's the problem. So I'm going to close this one and I'm going to try to start it again. And what if we just refresh? There we go. It's now connecting to my Azure Cosmos DB and it's showing you that information. Pretty cool. And even as you can see, I need to use my own troubleshooting tools to find out what was actually going wrong. Last thing I need to talk to you is how can I monitor my Cosmos database? So one of the things I already showed you is browsing data collections using the Data Explorer, but you can also enable scaling and using some other built-in monitoring. So without any further ado, let's go back to the Azure portal and walking you through some other monitoring features. So again, the Data Explorer I think is an important one where you can browse to your database collections and browsing your settings. Next to that, enabling scaling. So for now, it gives me the performance with a certain compute unit and an estimated cost. But nothing blocks me from, for example, moving this up from 1000 to, for example, 5000 and giving me 5 times more performance than what I should have by default. Another one I can enable is using built-in metrics. So what it does here is showing you a nice diagram. I'm using Central US, pretty easy for me to pinpoint. And it's going to show me some information about reads and writes. And again, there's not a lot of real activity against my database, but it's at least giving you a good idea about what's going on. It also shows you the throughput of the database, allowing you to get an idea about your throughput performance plans if you need to make any changes whatsoever. The amount of storage you're using, where again in my environment should be pretty low. Some other information about latency, consistency, all that. And even from the top of our Cosmos DB object, it's going to show you that basic information as well. So you can easily move around and use that monitoring tool that's built in inside the Azure environment.